Alright, this is essentially part 2 of the last video, where we covered just plain methods and about parameters and return types. In this video, we're going to start off with talking about out and ref parameters, which are special types of parameters, and then we'll look at some clever techniques and tricks people have used to get a lot out of the methods. And those tricks are why methods can be useful. They let you do stuff easily that would be really annoying to do without them. Anyway, enough rambling, let's roll the intro. Now, one thing that I want to remind us of is scoping. I've mentioned this idea before, but I'll go back over it again. Scoping is the idea that any variables declared inside certain curly braces cannot be accessed from outside those curly braces. So for example, if I just put plain curly braces, which you wouldn't normally do unless it's a loop or if statement or method or something like that, but if I did do this, any variables I make inside these curly braces cannot be accessed outside. So if I make a variable called str and try and use it outside, we get an error. We can't use str no matter what it's set to because it's made in here. However, if we make str outside of these curly braces, now we can access it here and inside these curly braces. So you can't access variables made within deeper curly braces is essentially it. Now the thing is, that also applies to methods since they have curly braces. If I make a variable inside one method, I can't access it inside this method because they're both in different methods. So we would have to use parameters all the time. However, a cleaner way we can make variables that we can access across all methods here, without needing lots of parameters, is to make them inside this class. So instead of declaring our variable here, we'll declare it up here. Now, two things we need to be aware of when we're making methods in here, and only in here. We need to put static in front of them. Once again, we'll find out what this static is all about later. And another thing is just a stylistic thing. If we're making a variable here, we should really be putting capital letters at the start of the name. It doesn't make any difference to the code, it's just one thing you should do. So now, because these are made here, anything at the same level as these variables or deeper, like anything inside the methods, can now access these. And anything outside of this class wouldn't be able to access them because of scoping too. Okay, next, I want to come back to an idea I just briefly mentioned in episode 13 about arrays, which was value types and reference types. Now, you'll remember that literally all I said was that value types cannot be null, and numbers and booleans are pretty much the only value types we know, and reference types can be null. Well, I want to look at what these are. Now, there's an important difference between value types and reference types. You see, if you have two variables, and you set one variable to the other variable, value types and reference types will behave differently. If we have a value type, then that value gets copied. And what that means is, if we change variable B, that change will not affect variable A, and the other way around. And reference types are the opposite. So let's try this out in the code. We'll use int for the value type and a character array for the reference types. Now let's make variable A and set it to 10, and variable B and set it to A. Now this is using int, which is a value type. So any changes I make to variable B will not affect variable A. So if we increment variable B by 1 using this, which if you remember will change the variable, it doesn't just give back a number like most other operators, then debug will notice that B has incremented forwards by 1, but A hasn't, and that's what happens with value types. With reference types, it's different. If we make these character arrays, let's try a similar thing. We'll change the third item on B to an exclamation mark. Now, let's look at what they're both set to. And look at that, both of them now have an exclamation mark at the end. So that's the difference between value and reference types. When you have a value type, they're both separate. Any changes you make to variable A will not affect variable B and vice versa. However, with reference types, they both refer to the same thing, to the same array. So changing either one of them will change that array. And this diagram right here is a perfect diagram of how it works. In a value type, they're both completely different memory locations. In a reference type, they both refer to the same object in memory. However, there's one important thing you need to know about this when it comes to reference types. This is only when you're changing something about the object, like adding to it. However, if we set one of the variables, what we're doing is making just that variable now change to refer to something else. So if I wrote b equals new character array of size 3, and make changes to that array, A will not change with it. Because what we've done in that case is we've changed what B refers to. I know that sounds weird, but if you look at this, it makes sense. We're setting B to A, making it refer to the same thing as A. But as soon as we actually set B to something else, it's no longer referring to A. It's no longer set to A. It's referring to that other memory location we just set it to. And all of this applies the other way around too. If I change something about variable A, it will affect variable B. But if I set variable A to something else, then any changes to that won't affect variable B. Okay, that's how it works. I know it's a bit confusing at first, but just to summarize, you have value types and reference types. With value types, no matter what you do to either variables, they're both completely separate and that's it. With reference types, when you set one variable to the other, they refer to the same array, since it's a reference type. If I change a certain item inside the array, that will affect both variables. We're changing something inside that array that they're both referring to. However, if we go in and actually set one of the variables, now, instead of changing this array, we're changing what the variable itself refers to. So now, they refer to different things, and they're both separate. Strings are also reference types, but I couldn't really demonstrate this with them, since strings are designed in such a way, where literally the only way to actually change a string is to set it. So I couldn't demonstrate this with them. So hopefully that makes sense. There's not too much to it. Now, how does this link to methods? Well, the same thing that applies with variables applies with parameters. Let me show you what I mean. Let me make a method. Let's just call it m for method. It'll be void. And we'll make it take in an integer, which we'll call b. Now, within our main method, we're going to put a number into a variable called a, and let's set it to 15. We're going to call method m and put in variable a as the parameter. So, as we know from the last episode, it's going to take variable a and put it into b for using inside this method. Now, you see, parameters behave exactly the same as variables. So, as we should very well know by now, an integer is a value type, as are booleans and all other number types like floats and things like that. So that means that no matter what I do to variable b, set it, change something about it, whatever, it will never change variable a, because b is a copy of a. These aren't references. However, let's try this on an array. Let's do a string array this time. It doesn't matter what type of data is in the array. It's still an array. Therefore, the array itself acts like a reference type. Now, as we know, an array is a reference type, so we're going to get something different. Let's see what happens now. Now, when we change something about variable b, it will affect variable a. Let's put an exclamation mark in the array. Now, if we debug, when we go into here, b is of course just one null item, because we just initialized a and didn't actually set any of the values. And then we set that one item to an exclamation mark. And now, both b and a have an exclamation mark like we've been talking about. Now, as I've said, if we set variable b, or even set variable a to something different, then they're referring to different things and won't match up anymore. I really urge you to, after this video, just mess around with as many data types as you can and see how they act. See if you can work out whether they're value or reference types, and post in the comments how you worked it out. It's good practice. Alright, now how does all of this link to methods? Well, enter a special type of parameter called the ref parameter. Now, this is only on parameters. There's no such thing as a ref variable, but there is such thing as a ref parameter. Now, ref changes things up quite a bit. Ref does exactly the same thing to both value types and reference types. It basically forces the parameter to become a reference. Now, you should only use it when you really need it, which shouldn't be too common, but let's take a look at how it works. So, to make a ref parameter, or the long name would be a by reference parameter, we simply write the word ref, R-E-F, before the parameter. Now, as I said, this is only for parameters. This doesn't exist on regular variables. Now, we also need to write ref before the parameter when we call it too, like this. So, now, we're adding 1 to variable B. What we'll find is it does change variable A. It works exactly like a reference type. However, on top of that, if we set variable B, it will also set variable A too. And this is exactly the same for reference types too. So, when we use ref, no matter what we do to variable B, it will always affect variable A, whether it's setting the variable or changing it. But as I said, you should only use ref when you need it. You should try and use it as little as possible. It's quite rare that you need to set a variable in here and have it change the original variable, but there are definitely some places where I've used it. The reason you don't need this too much is because I think mostly making variables up here is better than using lots of parameters. But over time, with experience, you'll get the idea of where you should use parameters and where you shouldn't. I can't really teach it to you. So, that's the ref parameter. Now, there's also one other type of parameter called the out parameter, and don't worry, this one is quite a bit simpler than the ref parameter. Now, one big issue we have is we can only return one thing, and this has been a problem that people have tried to solve in many different ways for literally centuries. Just recently, in a new C# version, they introduced fancy tuples, which is a nice way of returning multiple things from a method. And there are lots of other ways people have tried to provide this. However, one way that's also in C# is something called an out parameter. This lets us give out a value. So normally you'll have the main return type, and then sometimes you may, although once again not that commonly, have an out parameter. So here we have a method that takes in a boolean, and what we're going to do is also make a boolean in main. Then we're going to call this method passing in this boolean, so nothing special here at all. Then we're going to make this an out parameter simply by writing out here, and we also need to do it here too. Now, this acts kind of like a return value, and whatever we set this variable to by the end is what this variable becomes. Now, yes, you could do this with a ref, but it's nicer to use out for this, since it tells anyone who wants to use this method that this is essentially another thing this variable returns, in addition to what it returned normally. Out also behaves exactly like return. We must set it to something in all cases, just like with return. Otherwise, what is it going to put into the variable? So we have to set it at least once before the method exits or returns. So if I have an if statement and I just set this out parameter, then that isn't enough, because what's it going to set it to if this if statement is false? So just like return, we have to set this out parameter in all cases. Alright, now we technically know everything about methods. Now, before we get into some method techniques, we're going to take some of the tasks we've done and try splitting them up into smaller methods. Let's start with the shopping list task. Now, just a little fact for you, when you go back to some code and reorganize it to make it neater and nicer to work with, that's called refactoring. So we're refactoring this code. Now, there are technically things in Visual Studio designed to make refactoring code easier. So like, you can just highlight code and say, put this in a method, and it will move it into a method. But I don't want you to use those, because you're not really learning anything then, and it might do weird things you're not expecting. Anyway, the first thing I'm going to do is put this list in the class, so any methods I'm about to make can access it. We'll get rid of this comment. As I said before, I'm only adding comments to help make it clearer in these videos what's going on, but you shouldn't add this many in your projects. Okay, we'll leave the while loop here, but we'll split this out. All of this code is for the menu. So we're going to make a method and call it showMenu and put the code in there. Now, I'm noticing an issue here. At the end, we're making this option variable, which is of course for the rest of the code back in main. But of course, we can't access this in main because it's made in this method. One thing we could do is declare the option variable up here, then just set it. But what I would prefer to do is instead make this method return a string and make it return what the user put down instead of putting it into a variable, and we'll call it showMenu and give response. It's a long name, I know, but it's descriptive and tells you exactly what it does. If we went with the other option and just put the option variable up here, it's not obvious to someone reading this code that this method changes that variable. If they saw show menu, they would just expect it to show the menu, not be changing option variables. Sure, here you know that, but in much bigger projects, or if you go back to it in the future, you won't remember what all the little side effects of the methods are, which is why I prefer this way much more. Anyway, now all we'll do is call our method and take what it gave us and put it into an option variable. So this is technically the same as the previous code, of course. What happens is this showMenu and give response returns read line. So the user inputs something, and once they press enter, it takes what read line gave it and returns that. Then we just take that return value and throw it into the option variable. Let's keep going. Now, I want to split down this method even more. How about we make another method that contains all of this shopping list showing code? That way, anyone will just see show shopping list items instead of all this mess and instantly understand what it is without needing to work it out. So, let's split this thing out. Now, this doesn't change anything or give anything like that, so this will literally just be void, and we just dump the code in there and call it. Done. How about we also do these options here? Not the read line at the end, but these options. How about show menu options? That sounds good. And we call that too. Now, look at how much nicer this is. Instead of all that code, we can see there's one bit of code that shows the items in the shopping list, one bit of code that shows the options the user has, and one bit of code that actually gets what the user chose. Way nicer. Now, any programmers who look at this code can find exactly what they're looking for and easily ignore the things they don't want to see. Let's keep on going. Now, what I would do next is move all of the adding code into its own method too. Not the if statement. We still want the rough flow of how the code works to be easy to see, but we want to move all of this code, all of the specific details, into another method. Let's call this add item to shopping list, putting the code in there and call it in the if statement. And we'll do the same for removing items too. Now, we could split these down even further, but they're already a few lines of code long. I would say that they're all short enough now. But let's just stop right there, because as you may have noticed, we have a problem. There's an error on this continue, because it isn't inside a loop. Now, yes, technically, we are calling the method from inside a loop, but it doesn't work like that. The loop has to be inside the same method as the continue and break. But we don't want to move all this code back into there. So, we'll just have to do this a bit differently. There are two things we could do. Now, in some situations, we would need to run the continue or break. So, for something like this, I would make it return a Boolean saying whether it was successful or not. So true means it succeeded and false means it failed. Then whoever is calling just puts that into a variable, and if it's false, it could just run continue. So here we could make it return false. So if what they entered wasn't valid, it just jumps out of the method and gives back false. Then of course, if they did enter something valid, it would go down here and return true. However, for what we want, we don't really need any of that. When you really think about it, if we gave an invalid input here, it's just going to go down and go around in the loop anyway, so it doesn't really matter. So we'll keep it void and just return from here. So we aren't actually giving anything back. The method will just stop running as soon as it gets here. So that way, if they inputted something valid, it won't remove the item from the array because it gets stopped here. And that's it sorted. Alright, we split this project up. Let's look at some clever things you can do with methods now. Let's look at how to use them effectively. So here's what we're going to do. We're going to make a method that takes two parameters. One is a string array, and another is a string. And it's going to return a boolean. What this method will do is it will scan through the array we give it, and if it finds this item anywhere in that array, it will return true. Otherwise, it will return false. So, we'll call it array contains. Now, without a method, this would be a bit of a pain to do, but by taking advantage of how return just jumps out of the method, we can do it quite easily. Now, there are different ways of doing this. Some can be more efficient than others in certain cases, but this is definitely the simplest way to do it, in my opinion. It's kind of elegant how small and compact it is, but that doesn't mean this is the best searching algorithm. What we're about to make is called a linear search. So what we need to do is we need to go through each item in this array and check if it matches what we're looking for. If it does match it, we'll return true. And if we get all the way to the end of the array without finding a match, it returns false, because it went through the whole array and didn't come across that item. So to put that into code, we'll have a for loop that goes through each item in the array. So all this again. Then we'll have it compare this item to what we're looking for. So we'll put in an if statement comparing this item in the array with what exactly we're looking for. Now I'll explain this in a moment, but in here we'll put in a return true. Then, outside of all this, we'll put in a return false. Now, let's debug this to demonstrate this. Here, we have an array with three strings, A, B, C, D, E, F, G, H, I. Then, we're telling it that we're searching for the string D, E, F. So, this will return true to tell us that it did indeed find that item. But let's see how it works. So, we have three items in this array, of course, as we can see here. Now, we compare each of them to what we're looking for. So this is the first item. It doesn't match and the loop goes back around again. Now we're on to the second item. Now this does match, as we know. The array's second item is DEF and we're searching for DEF. So these do match and now it returns true. So just like that, it instantly stops what it's doing and it gives back true. And that's perfect. It doesn't need to search the rest of the array. There's just no need. We confirmed that there is that item in the array. There's no point in looking through the rest of it. Now, what happens if we search for something that isn't in the array? Well, it's quite simple. If we look for literally the string A, then this will give back false, of course. There is not a single item in this array that is literally just the string A. Let's debug what happens when we have an item that doesn't match. So, it goes through each item and it checks each item and none of them match. So eventually, it hits the end of the array. And still, the return true here hasn't run. But since we've now reached the end of the array, without being stopped by this return true, it exits the loop and returns false. So hopefully you can see how return can be used in quite a clever way. And as I said, if I just remove all the curly braces, this is such an elegant, small thing. I would also like to point out that there is, of course, already built-in methods to do this for us, but we won't learn anything if we just use the built-in things, although if you are working in a professional environment, of course, you would use the proper methods that they provide. Alright, there's also one more technique I want to look at. It's called recursion. Yes, this technique actually has a name. It's recursive programming. And the idea is you have a method that calls itself. Now, if you're not careful with this can crash your program. Don't worry, it won't break your computer or anything, but it can crash your program if you mess it up, which obviously isn't really a problem because you can just go back in and fix it, of course. If you're curious what happens when you make a method that calls itself, go ahead and make one. Then, call it once from main to get it going into that endless cycle. You'll get a Stack Overflow exception, which is where the website Stack Overflow essentially got its name. Now, we're going to look at something that can be done with recursive programming easily, and that's working out the factorial of a number. And recursion can be neat, because it means you can sometimes do things without needing any loops, and by extension easier. So, in case you don't know, the factorial is all the numbers starting at 0 up towards a given number multiplied. If you imagine you have the factorial of 4, what that's essentially equal to is 1 times 2 times 3 times 4, which is 24. So the factorial of 4 is 24. The factorial of 5 is 1 times 2 times 3 times 4 times 5. Now, we could do this with just a loop, probably for this particular example quite easily, but we can also do it without any loop and with a recursive method, and it's really simple. What we'll do is we'll make a method called factorial of that takes in an integer, and this works out the factorial of a number. Now, if we just look at the factorial of 5, for example, what's the factorial of 4? It's 1 times 2 times 3 times 4, right? What's the factorial of 3? It's 1 times 2 times 3, and so on. So, if we want to work out the factorial of 5, we can just do the factorial of 4 times 5. If we want to work out the factorial of 4, we just do the factorial of 3 times 4. And so on. To work out the factorial of 3, we do the factorial of 2 times 3. We can do this recursively. Let's make a method that works out the factorial of a number. So it takes in an integer, which is the number we want to work out the factorial of. Let's just call that n, and returns an integer, which is of course what the factorial of that number is. Now, at its absolute simplest, and this isn't the whole thing, but this is one part, what we're going to do is work out the factorial of the last number and multiply that by this number, just like I demonstrated earlier. So let's think about what's happening here. If we imagine we give this 5 to work out the factorial of 5, first it's going to work out the factorial of 4 and take whatever that gives us and multiply that by 5. In order for it to work out the factorial of 4, it calls this method but passing 4 as the parameter. To work out the factorial of 4, it works out the factorial of 3 multiplied by 4, and so on. Now, there is one problem with this. This will just infinitely go on and on and on. Let's debug it. We'll try working out the factorial of 5. We get into the method, and n is 5, of course. Then, we're going to return the factorial of n minus 1, which is 4, and multiply that by 5. Now, in order to do that, we need to actually work out the factorial of 4. So, it first calls factorial, but this time with n as 4, since that's what we gave it. Then, this also calls factorial, this time passing in 3, which then needs to work out the factorial of 2 to do this, and so on. This will just go on infinitely. It's going to keep on going even into negative numbers. It should stop at 0. Now, what's the factorial of 0? Well, it's 1. So literally, all we're going to do is check if n is 0, we just return 1. Otherwise, do this. So now, it's going to call itself over and over again until it hits 0, where it's then going to return 1. Think of it like this. You've got the first factorial with 5, and it needs to work out the factorial of 4 and multiply it by 5. So in order to do that, it calls itself to work out the factorial of 4 instead, which then calls 3, which then calls 2, then 1, and then 0. Then, at 0, it checks if n is 0, and sees that it is, and says, oh, n is 0, we're going to stop here, and gives back 1. Now that this one has returned, 1 can now multiply that and return that. Now that 1 has given back the answer, 2 can now return, and so on. So it's like it goes down, then back up again. And finally, the factorial of 5 can then return to whoever called it, and they have their answer. If you don't understand it now, then that's completely fine. We'll take a bit of a break in episode 17 and go back over things there, and do something a little bit different. Anyway, tasks. Go ahead and go onto the website. The first task is members only. Essentially, you have to use the linear search method from earlier. That takes in a method and what you want to search, and returns a boolean saying whether that array contains that item or not. If you don't remember the code, see if you can write it yourself. Go through each item in the array, check if it matches, and as soon as it finds a match, return true. And if it gets all the way to the end without finding a match, return false. Anyway, thanks for watching. I'll see you all in episode 16 to talk about classes. Then, in the episode after that, we can slow down and revise what we've covered so far. Bye!